Yes, welcome back. Good afternoon, everyone. Today we will discuss topic enantiomeric access and how it is how it can be determined by using different technique, including NMR spectroscopy. See, if we will take 50-50% two enantiomers, and it is called as enantiomeric mixture, or it is called as reciproc mixture. Generally, it is the mixture is composed of two isomers. We call them as enantiomers. One is R and another will be S according to CIP rule. Kahn in gold rules are there to give the nomenclature for the chiral molecule R and S. So when we have a pure one enantiomer, and it is called as a optically pure or it is called as a homochiral. When we have an equal percentage, 50-50 percentage of this both R and S, it is called as reciproc mixture. But we should know that between a reciproc mixture and optically pure lies a range of unequal mixtures of two enantiomers. For example, if we have a pure with this in our hand, this one, and suppose we are having one R with us, and we are adding S small in a small portion to that R. Okay, so we are adding and we are going to add continue till it reaches to 50-50%. So between this range means from optically pure to become a recipe mixture, there is a range of enantiomers mixtures. They are called unequal mixtures, and one unequal mixtures containing 50-50% they become recipe mixture. Okay, and see, when we measure the rotation of PPL light, plane polarized light, by using polarimeter, we will get the recipe mixture value as a zero. What we have seen in the last lecture yesterday. Okay, if you measure the optical activity of by using polarimeter of this pure compound, you will get exact rotation, positive or negative side. So if it is pure, you will get more optical rotation or optical activity, we can say. If it is negative, still you will get the optical activity in a negative sign rotation. Okay. So if you want to take two examples, lactic acid, this is lactic acid, and this is another lactic acid. There are the mirror images. Suppose this is a plus lactic acid, this is a minus lactic acid. When you rotate this plus lactic acid, suppose it gives the rotation, specific rotation, alpha D. It's called as alpha D, the plus 3.0. So the alpha D for this would be exactly opposite, the minus 3.82. Means clockwise rotation and anti-clockwise rotation. When we take pure lactic acids, either left or right, okay, plus or minus. But when you keep adding these two lactic acid with each other until the equal percentage reached, plus lactic acid and minus lactic acid, when you add these two lactic acid, when you add mix with each other, slowly mixing if you start. Okay, so what will happen? At one end, we will get the recipe mixture. So it can be understood by this diagram. You see here, if you see here at this point, you see at this point, it is a pure what? 100% what? plus 100% plus. And what is this minus? It is a 0%. So if you see the optical rotation is maximum, that is what? 3.8. See. Now what do you do? Add this minus 25% and this 70%, total is 100. And when you count its rotation, this is a rotation axis. So it can like this. You can connect this like this. This is 1.90. When again you add, if you add again, you decrease 75 to 70 and this becomes 30, you will get another value, decrease rotation. And you add keep going and you did 50% and it is 50%. So at 50% receiving mixture, rotation is zero. Here, see, rotation is zero, like this. Now continue. You can add 60 this and 40 this, 60 this. You can add, so you'll get rotation like this, minus rotation like this. This is this blue line indicating the negative rotation like this. It will come. And you keep adding, you reach the 25% of this plus lactic acid and 75% of negative. So and if you connect it, see like this. If you connect like this, so if you connect like this, if you connect like this, so here somewhere you will get negative value of this rotation and keep increasing, keep going. So when you have the 100% minus lactic acid, this one, and 0 plus lactic acid, rotation will be 3.82 anti-clockwise rotation. So this is the graph we can derive from the polarimeter. Polarimeter helps here to find out whether the compound is racemic or not based on the rotation value. So if we change the, here we have taken the lactic acid. If you take another acid, suppose we are using glycerolaldehyde, suppose this is a glycerolaldehyde, okay, fine. For example, if you take glycerolaldehyde, see here. So what do you say for this one? If you take example of glycerolaldehyde, see here like this. This is a glycerolaldehyde, suppose. There is a CHO group. Then here we have this side, one side we have OH, and here we have CH2OH, and one group we have H, right? Yes. So this is about the example of glyceraldehyde. This is a, if you what you can find out this rotation also, no problem. What is the rotation? What is the name RRS? You can label it. If you take this of one, suppose this is a one, okay, we can label it. Suppose it is a one, so this will be two, and there is an anticlockwise. But fourth group on horizontal is a what? R. So if you take this R, it is a glyceraldehyde. Okay, what is this? This is a R glyceraldehyde. So you can write as a R, or you can write a positive also, no problem. Glyceraldehyde. So see, if you take this one, suppose this is a R glyceraldehyde. Okay. So by having this R, we can go for the, okay. So we can have a R glyceraldehyde at the place of this one, and we can also find out its rotation by using polarimeter. So hope you understand this plus lactic acid and minus lactic acid. When we have a pure here, so it is a plus pure 100%. It is a plus 3.582, and is it is a standard, okay, reference value. Whenever sample is given to you and they have asked you find out whether it's a pure or not. So what you do, you find out, go to the polarimeter, take the sample and find out. If it is 3.82, you can see sir it's a plus lactic acid. Another sample is given to you and question us, go and check the polarimeter, its rotation, and you find minus 3.82. You can see it is a minus or minus lactic acid. Similarly, if you are third sample you have taken and you went for polarimeter and checked you have performed the experiment of polarimeter and you found that it is a 1.91 rotation. It means that it is a mixture, not recipe mixture. It is a mixture. It must contain positive means value means more amount of R or this poly plus less amount. Suppose you got minus 1.9. Suppose one here, one minus 1.9. It will appear somewhere. It means that uh, the the mixture is containing minus lactic acid more amount and plus lactic acid in less amount. Fine. So see here, this table also help us to understand the idea of how to find out the enantiomeric excess. So racemic mixture is the mixture of 50-50% enantiomer. One enantiomer is 50%, another enantiomer is 50%. When we have 100% plus lactic acid and 0% minus lactic acid, then it is called as optically pure, right? Yes. Or you can reverse it. You can take 100% minus lactic acid and 0% pure, 0% 0% plus lactic acid. It will be pure, but here will be minus sign, right? But in this case, to understand the idea of enantiomeric excess, we have taken 100% plus lactic acid and we have taken uh, 0% minus lactic acid. So it is optically pure. Why? Because it is having only plus lactic acid. When you have a 50-50%, definitely they will cancel with each other. Rotation of the plane polarized light, and you will get what? A racemic mixture, which give you 0 degree rotation, right? Zero degree rotation. And the third condition, when we have here 50-50% is given, here unequal amount is given. Suppose we don't know what is x, what is y. This is our most important point. We don't know what is x, what is y, but one point is clear: x is always higher than y. This is considered. Okay, you can take x. Suppose you can take 55, y will be 45. You can take x is equal to 60. This will be 40. You can take 70. This will be 30. You can take 30, 75. This can be 25. You can take 89. This will be 11%. You can take 99. It can be yes 1%. Like this, you can take a 99.5 also possible. 0.5. So you can combination should give you 100%. You got it? You are getting this point? You can take, but more than one will be more than 50%. That should be considered. Okay. Only such mixture is called as the unequal mixtures of emulsions. And when you have such type of mixture, this will give 0 degree rotation. When you take such rotation, such mixtures, this mixture always give you very different rotation value, and it must be negative or positive, but never zero. Zero rotation will be given by only the mixture which are from those mixture having the 50% lactic acids. Okay, right. So like this we can understand these concepts. Okay. So now there is a how to find out the recipe mixture or enantiomeric excess from the given mixture. So it is x minus y, but consider x should be in the more quantity. X should be in the more quantity. For example, see here, suppose a mixture, there is a mixture suppose which having 75% plus lactic acid and 25% minus lactic acid, and this sample is given to you and asked you check the uh, which is having the more amount of or which enantiomer is there. So this is the formula you have to use. This is the formula going to be applied in enantiomeric excess. How to find out? So how will you get it? So 75 is this one and 25 is this one. So result will be 50% will be enantiomeric excess. So like this we can apply this idea. We apply the formula and find out the we can theoretically we can find out very simply. It is a very simple method. Okay? Let us go for further concept, explore idea. To calculate the proportion of each enantiomers, we can find out that if enantiomeric axis value is given to you, so based on that enantiomeric axis value, we can also find out the proportion of each enantiomers. It's very important again. We can find out the proportion of each enantiomers. मीन्स जर आपल्याला सपोज एक आपको दिया है इनैंशियोमेरिक मिक्सचर का वैल्यू दिया है सपोज इनैंशियोमेरिक एक्सिस वैल्यू इज गिवन suppose initially x value is given, so based on that what we can do, suppose e is given certain value, okay, certain value is given, okay, right now, and based on that what we can do, so we can find out, yes, we can do this, we can find out the proportion of each initial. See, we can do vice versa. Having the proportion of enantiomer, we can go for the calculation of enantiomeric axis, or we can also find out the, yes, we can also find out the proportions from the, 1 minute, okay, 1 minute. So let's go for example. See, suppose there is a value given to you. The enantiomer axis value. Suppose they have given you value this one 60%. This is the value we have. It means 60% is optical pure, and 40% will be mixture in that sample. 40% should be divided into two isomers because we have two isomers. So that will be 20%, 20%. So that one is which is a 60%. So we add up to one more 20%, that becomes 80%, and another will be 20%. So like this, we can say the ratio of proportions of enantiomer will be 80 to 20. So simply you can take, see here, very simple. If you have this idea, see, if you have this one, for example, so for example, this suppose this 80 is suppose x and this 20 is y. So 80 minus x minus y means 80 minus 20 is 60. So this x will be 80% and this y will be 20%. Right? So like this we can find out. So now see, there are actually four methods to find out the enantiomeric axis. We have a four method in by which we can easily find out the enantiomeric axis. First one is by measuring polarimeter, just we have seen, finding the rotation clockwise, anti-clockwise. Then measuring the enantiomeric axis via sample derivatization. This is we have seen also in the last lecture. Chiral chromatography also a technique can be used to purify the compound of enantiomeric mixture. And by the use of chiral additives, okay, if we are using chiral additives in a by NMR technique, we can also find out, for example, chiral shift relays. By the use of this technique also, we can also calculate the enantiomeric axis. So okay, hope you understand this. So, for example, you see here, we have seen one more example we have seen, that is what, the use of mandelic acid for the uh, derivatization of the mixture, recipe mixture. So here mixture is given. Again, I am not telling you recipe mixture. It can be unequal mixture, right? So when you react this with a Mosher acid, this is a pure Mosher, is suppose R. It is a Mosher acid, is a pure R. So this when react with this, so we know this amine group react with this acyl group called as amination or acetylation. Acetylation will take place, very famous reaction of amine. So this will form. This R will be in both the, it will be R only, right? In both the product. Two compounds will form. How? This moisture acid will react with one of the mixture R. This will form this one. And this another moisture acid, another molecule or half part of moisture acids, acid will, acid chloride will react with this S in a sugar and will form this one. So this will be RR, this will be SR. Now, these two pairs are called as diastereomer. Remember this. If it would be, suppose what you say, this is the RR, and suppose it would be R. This would be, suppose this is RR. So this is R, and this is also suppose R. Then called as a homomers. And if it is RR is there, and this would be SS. So this will be the enantiomer. But this pair is neither enantiomer nor homomers, because one one chiral center is different from this one. One is okay. Second chiral center is different from this one. So such pair is called as diastereomers. And remember, diastereomers, we have learned many points, many examples. Diastereomers in NMR spectroscopy, they always give very different chemical shift. Very different chemical shift. Right? So once you have these two compound, once we have these two compound in our hand, so we can separate them by a technique. For example, say column chromatography. Okay, see many techniques are available, so we can use them. Okay, we can use the techniques and we can separate them. Okay, and we can find out even by without separation also we can go for to find out the by based on the peak value integration. We will see example. We can find out, we can check the how much amount of S is present and how much amount is present. Now, can we say deprotect this group? Yes. You just add NOH or this will remove this group, and this also, and you can separate these two compounds. Fine. For example, see, there is a mixture of pentanol, two pentanol. It is a chiral but mixture. Two compounds are there, plus and minus. And this is a what? Moisture acid, right? Just we have seen right now. This is like this moisture acid. Okay, fine. Okay, moisture acid type 1 is, we have taken one pure compound. This is a kind of a derivatizing agent. This is called a derivatizing agent. Derivatives making agents. It will form two compounds. You see here. It will form two compounds. In one, it is what? It is suppose this R, this will be S. This S, this will be vice versa. No? Now see, these are diastereomeric esters, right? Yes. These are, and diastereomers we know always give a different NMR values in the spectrum. Okay, and they also have a very flow rate. If you take a column chromatography, these two will flow at different rates. They are not equal. Remember, these are, though structurally they are same, but this chemically they are not equal. They are diastereomers. They are different compounds. You know, see, you can separate by them chromatography. When you add NaOH and water to these compounds, you can get two pure compound. By chromatography, you will get this one. Just you add NaOH and H2, you will get pure propane to R, and this will be propane to S. Fine, like this. Okay. So this is what about the idea of uh, use of chiral derivatizing agent to use and to separate the uh, mixture by using this technique. Okay, right. So we will stop now here. This is what about the enantiomeric axis calculation.